My name is Emmanuel from Commonwealth Automotive Engineers. Today I'm here to teach something about electrical network. Okay, and the electrical network, what I'm coming to teach is series circuits. Okay, when someone asks us that, what is series circuit? But before then, let me draw my circuit so that we can understand the whole thing. This is my circuit, this is my battery with one resistance connected in series. My current is going to this direction. This is my V0, and this is my R1, and this is my I1. I'm having only one loop, and I have assigned to my polarity, which is positive and negative. So when someone asks, or a lay person, or somebody that have not understand something about physics or electricals, and the fellow asks you that, what is series circuit? Okay, a series circuit is a circuit that has only one path. The reason is, when we start from somewhere here and we move along the circuit, we'll end up where we start, because there is no any other path here that the current will go, or that will go when we are moving around this circuit. Okay. In a series circuit, one thing that we need to know for sure is that current is constant and voltage vary. So let's say we have a loop, we have a node. Sorry, this one is called node. This is what we call node. The node is this resistance have been connected to this battery. But we have one node here, which they all share the same one node, which is the ground. And we call it a reference node. A reference node. Okay. Now our point of intention is the access to find current. The access to find I1. And we don't know what I1 is. So we need to use algebraical equation to find the I1. So finding I1, one thing I want you to know for sure is that, let me write the potential, or let me write the electromotive force. This is the symbol of electromotive force. In some of my presentation, I'll be using E instead of volt. So the E stands for electromotive force. And this is my positive polarity, and this is my negative polarity. When the current is moving from here in this direction, it's a voltage rise. It's a voltage fall. When the current is moving to this direction from negative to positive, it's a voltage rise. So rise in voltage, which is V. Let me use the V. Rise in voltage, or let me write the whole thing. Rise in voltage, and this one is fall in voltage. fall in voltage. So rise in voltage and fall in voltage. So now we want to use the algebraical equation to find the I. So you know that when current is moving from here, you are moving from the negative region to the positive region, voltage rise. You are moving from the negative, we are moving from the positive region to the negative region, voltage drop. And because there will be a voltage drop here in the resistance. So they ask us to find current. So let's see how we find the current. Even though that we have an Ohm's law or Ohm's formulas, we have something we call Ohm's law let me clean it all. Ohm's law or Ohm's formula. And I'm going to show you something we call the Ohm's triangle too. Ohm's triangle. I'll show you how to use Ohm's triangle to find the Ohm's formula after I finish finding the current in this resistance. So let's say the current is moving from here, so from the negative region to the positive region, so which means voltage rise, so V0. Now the current move, we have not made any resistance. The only place where the resistance is this place. So voltage drop. So there is a drop in voltage, so which means the current is moving from the negative region to the positive region, positive region to the negative region. So that will be I1, negative I1, negative R1, I1 is equal to 0. The reason is that when we move from here, we come to where we start. So we equate the whole thing to 0. This is what we call the Algebraical equation. And now because they ask us to find currents, we can rewrite this thing V0 is equal to R1, I1. They ask us to find current, so current I1, I1. So this will cancel this. So therefore, V0 over I1 is equal to I1. Or I1 is equal to V0 I1. This is the same as this. So I hope you guys understand. Now, let me quickly show you how to use the Ohm's triangle to form use the Ohm's triangle to form the Ohm's formula. You can also use the algebraical equation to find the I or to find the resistance, whatever you want to find. When they give you some values, but here they say that we should find I1. So the I1 is what I find here. So when they give you some values, let's say 12 volts, and let's say 10 amps, let's say 10 ohms, sorry, 10 ohms. Now you can plot these values in the variables, the alphabet that can root your this equation that is here. So this is what is the voltage and this is resistance. So I know my voltage, which is 12, and I know my resistance, which is 10. So the only thing you do is that you just plot the whole thing into any one of these, and you get the I1. Okay, let me quickly also show you how to use let me clean this side. Let me quickly show you how to use the Ohm's triangle to form a formula. So this is the Ohm's triangle. This is the Ohm's triangle, and this is the V, and this R, or let me say I, and R. Let me clean it so that you can see it. Let me rewrite it again. So this one is I. Now we use this alphabet as a terminology to designate certain things. In electricals, most of our time we use an alphabet to designate certain things. But here, the V stands for voltage. And here, the R stands for resistance. And here, the I stands for current. Okay. Now, if we want to find, and this, you see that there is a partition here. This partition, this one is a division. A division sign. And this one here, oh no, I'm mistaken, sorry. Yeah, this, yeah, it's the same thing. Yeah, I'm not mistaken. And this one is a multiplication sign. Okay? Let me take one chalk here. So, if I place any one of my hand on this alphabet, what it means is that I am standing alone. So let's say we want to find voltage. So the voltage is going to be something like, so I place my hand here, so what means is that we are finding voltage. So the voltage formula is going to be V is equal to I times R. So you can put them into parentheses if you want, or you can just do them like this. It's the same thing. Or you can say into parentheses R. If you want to find I, then we can say I is equal to V over R. If you want to find R, you place your hand on any one of these, then which means R is equal to V over I. Okay. This one is a voltage formula, this one is a current formula, and this one is a resistance formula. So let me find some clues. So the other one here, the V, which is this one, which is R, which is V, is equal to I over R. It's a voltage formula. And this one is a current formula, which is the I is equal to V over R is equal to current formula. And this one here is a resistance formula. So this one is a resistance, which is the V over I. So it's a resistance formula. Okay. So I hope you understand this. So anytime that they give you a very simple circuit and they ask you to find current, voltage, and resistance, and and the formulas escape you in mind, the only thing that you need to do is that you quickly go to the Ohm's formula, the Ohm's triangle. This one is the Ohm's triangle. Ohm's triangle. I hope you guys understand what I'm explaining here, or what I'm teaching here. I hope you guys understand. It's very simple when we are doing a very basic electrical calculation. But as time goes on, I'm going to teach you the complex one. Maybe next week I will teach you something we call a parallel circuit, and it also has its own formula. But one thing I want you to know is that the algebraical sum of the two resistors, like I should have shown you that one earlier on before teaching you the formula, because the thing they are in series. Let me quickly write it because I don't have much time. So let's say this is my circuit, and this is my V0, my I1, and my R2. My I1. My current is moving to this direction. I've assigned to my polarities. In series, it's algebraical sum. Let's say, for instance, we have another resistance in series. So what is going to happen is that, so this one is going to be R1 and this one is going to be R2. So you will just add them, which means the R1 plus R2 is equal to R total. So when you add them, whatever you get is your R total. Then you quickly come to here because they ask you to find current. So this is my current. So you just plot the R total here, and you know what your V0 is here. So you plot it. So I should have even teach you this one earlier on before teaching you the Ohm's triangle. So see you next time. Bye.